fuck. Okay, I need to... Oh, okay. So this is me checking if this stuff works. I think I'm live. Okay, we're live. We are live. We had a small mishap with logging in. I'll explain that in a bit. But given that this is now the stream that is actually working, I'm going to go on the socials and actually notify people that there's a new link. So, new link. Sorry about this. All right. Just post it to Twitter. Let's also do the other one. A new link. Let's post. And I think I had like another one. Give me 5 minutes. Sorry, this is kind of an annoying thing that happened here with the streaming software. But actually, I think yeah. So we're live now over at. Yeah, let's share that. And let's do this thing as well. There we go. And I'll also post there a new link, exclamation point. And there are people sort of joining it now, so that's definitely good. If you could say hi in the chat just so I know that stuff isn't fundamentally broken, that'd be sweet. But basically what happened was my local software, I'm using OBS, I was logged into that and everything was fine. But then it turned out that the login that I had was for my personal account, not for my brand account. And it only figured that out as I was trying to do the live stream. And the base behavior of YouTube, apparently, is to then kill the live stream instead of saying you can't log in. Will definitely do my best not to have that happen again. But, okay, here we are. I'm going to give it like maybe another 3 to 4 minutes. Then we can go ahead and get started with this live stream. Hopefully it's not too much of a bother to people. Again, sorry, folks. Kind of a mishap that happened here. I'm just going to check a few places one more time. Let's also check the LinkedIn one more time if people are responding. Oh well. This is indeed starting to look pretty good. Right. I think that's about everything I can do in terms of getting people in. So with that stressful moment out of the way, I guess what I can now do is maybe start talking a little bit about the idea behind this stream and what we're trying to get at here. So first things first, hi, my name's Vincent. I work over at a little company called Probabl. You may have seen the website, probabl.ai. And you might also know that I have colleagues, some of which are Scikit-Learn maintainers. We are definitely like an open sourcey company. That's definitely what we're trying to sort of get at here. But at some point, we did some educational videos on Scikit-Learn features, and that's been pretty popular, so we're really happy with that. But then we figured it might be good to experiment with a live stream as well. There's a couple of reasons for that. The first one is that it would allow people like you tuning in to just ask me questions directly. Every week I'll try to pick up a topic, but the ability to ask questions is also something that a normal YouTube video doesn't do as well. There's comments, but something about being able to do something live is also just kind of interesting. We also figured it'd be kind of more interactive, so as I go along on a train of thought, I can actually get feedback from, the larger community if there's a topic that's interesting. And it's also kind of nice because we also, there's GitHub, we can talk about issues there as well, but something about doing this live also feels like it's worth the experiment. But moreover, like the real reason why I was particularly interested in doing this is there's a couple of these ideas that are just a little bit too experimental to push out there as if it's a good practice. Like a couple of things are known, but a couple of things are still just a little bit more experimental. And a 10-minute video tutorial would typically maybe not cut that. So something about being able to just discuss in the open an idea that we're exploring, something about that is also just kind of nice, where we're working on something maybe that doesn't have to be taken super serious just yet, but there might be like fruitful ground for discussion. So that's something that this series of videos will also go ahead and explore. So hopefully that's been enough context, and also I can see that more people are joining, so that's great. Which means I can now get to the meat of what I would like to discuss here, which is all revolved around this one little data set. We're going to do something serious with this in a bit, but one of my favorite data sets out there is the World of Warcraft access logs dataset. It's originally found on Kaggle. I'm loading it locally here. And effectively what it just is, it's this log of people playing this World of Warcraft game. So just to look at one row here, there's a player ID. This player logged in. This player was a level 26 orc, orc hunter to be specific. And at this point in time, that user was in a place in World of Warcraft playing a virtual video game. And this person also had a certain level and was part of a certain guild. There's like information that we know. And the way that this works is every 10 minutes that you're logged in, we are going to see a timestamp appear right here. So you can imagine if you were playing for just 10 minutes, we might just have one row. But if you're playing for like 2 hours, we'd expect to be like 12 rows, so to say, that are all kind of in sequence. So that also means that we are tracking you over time, you could say. We can see where you're moving. We can also do stuff like how long have you been playing and when do you level up. World of Warcraft is one of these games where, you hunt monsters, then you gain experience points, then you level up. That's kind of the way it goes. But we have a full access log on this. This is a full server, and this has all the logins from the Horde faction on that one server of World of Warcraft. And one thing you can do that's actually kind of fun and interesting is you can actually chart what that looks like. So let's just run that cell one more time just for good measure. So here is just the number of people that are active on this server in this one data set. So what I can do is move it around, but I can also zoom in. One thing that's kind of cool here is that you can definitely see that there's like a weekly pattern. So I can hover over, we can check the date, and we can see that, it goes up, it goes down again. It's definitely something that's weekly here. But another thing that's also just kind of interesting is that you can also see that at some point the usage just whoop goes up. And it happens twice here, which I thought was interesting to just sort of dive into a bit. Because you can kind of wonder, well, what sort of thing can happen where suddenly the user base or the activity just doubles? That felt kind of interesting. So this is one of those rare occasions where one goes to the Wikipedia page of World of Warcraft to try and figure out like what might be causing this popularity. So it turns out during this period of time over here, like November in 2006, it turned out that there was an expansion pack. And you can have a look. It's the Burning Crusade. It was released in January of 2007. But this first jump up correlates with the announcement that there's going to be an expansion pack. And there was like a reason for people to join the video game. So I thought that was just kind of interesting. So, okay, that explains this one. And we also had another one going up there that took a little bit more digging on Wikipedia. But what I thought was pretty interesting there was Blizzard actually invested in marketing campaigns here. So they had like pop celebrities like Chuck Norris, I think also Mr. T. And what they did is they made little video commercials where they would talk about their World of Warcraft character. If you played World of Warcraft as a kid, you might remember this. I certainly remember that. I also think it's pretty fun that they also had like a French commercial with a Jean-Claude Van Damme. Like they actually went international with this, and they tried to do something cool with it. But you can definitely see that had a huge spike up as well. But then, like, as time moves forward, you can also see the usage just kind of goes down and down and down again. And that is despite the fact that there's actually a lot of expansions that came out as well. So I think in 2008, which is, let's just get the date, November 13th, 2008, that is part of this data set. So this is when also an expansion pack came out, and you can't really see like a spike going up. That's something you don't see in this data set anymore. Another thing that I also thought was just kind of interesting is you look up on initially like you're looking for reasons why there might be some spike going up here, and initially it seemed like this was happening around April Fools. So you start Googling like what happened around April Fools in World of Warcraft. It turned out that they were actually releasing a tinfoil hat, which I thought was kind of interesting and fun as well. Like that's an item you could sort of get in the game. They were sort of joking about that. But anyway, we can have a lot of these theories on what is happening, but one thing you can now also do with this data set is you can pretend that you're Blizzard for just a moment. And what's especially interesting is this stuff going down. Like, you can definitely see like some marketing had a good effect, and you can also definitely see that at some point in time, a new expansion pack definitely helped. But as time moves forward, the game is no longer new, and you do notice that people stop playing. So it might be fun to see if we can try to predict that. Like if you're in marketing, this is like churn analysis is what this is typically called. This is something that's usually, at least, like something that's very much of interest. Like, can we predict when someone leaves? And in this case, I'm zooming in on like World of Warcraft, which is a fun example that I happen to have a data set for. But you can easily imagine that this sort of stuff also happens with like telco providers or maybe even Netflix. Like if we can maybe predict that you're about to leave for whatever reason, that might also be a moment where we are able to sort of convince you to stay. And there's all sorts of market incentives to do stuff with that information. So, okay, your first inclination then might be like, okay, what can we do to actually make such a model, right? So let's write a little bit of code for that. I prepared a little bit of code below, but in order to explain what's properly happening, I think it might be good to just code this a little bit live first. So here I'll go. I have this data frame that I've got. And what I'm just going to go ahead and assume is that I'm interested in predicting whether or not you're still around after 2008. Like in this little period of time. From about here to about here, like I want to build a model that predicts if you're going to be there. So that means I would have to write like a little bit of code to get a label for that. So I would write data frame. Let's group by the player ID for now, and I can then do an aggregation by doing something like, hey, what's the max date time that you've got, right? So for every player, I'm going to calculate what's the last time that you were around. And note that I'm doing this in polars, and polars has already detected that this is a date time column, so it should be able to interpret this max well. There we go. It seems that we have about 90,000 users, and you can definitely see that some of them were around after 2008, some in 2009. That's also really cool, but you can also see that some users just stopped really early. So these are users that may have left, so to say. So let's organize this just a little bit such that we can read top to bottom, left to right. One thing that I can do at this point is I can say, well, having that date time is really nice, but I want to turn it into a target variable, something that I can predict. So I can do something like with columns, and I can say there's a target variable that I'm interested in, and that is going to be the date time column that I've got at this point in time. From it, I'm going to just grab the year real quick. This is a polars thing. Because this is a date time column, it has access to this assessor, which is a collection of date time methods. And I can just grab the year. So that's super cool. And what I can say is I want that to be higher than or equal to 2009. And that would immediately, or actually, yeah, that could work. That actually could work. But maybe we can also, let's do it simple. I guess I'll just do something like larger than or equal to 2008. That means that I'll be checking if you're going to be around in this period of time, which is a different period that I thought of initially, but this should also work. It's still like a good set of data to train on and a good set of data to test on, so that should actually be fine. And this makes sense. So I've got a row here, 2008. Something is the highest date, so the target for that one would be true. That totally makes sense. I'm going to drop the date time for now, though. But what I've got now is my target variable. Like for each player, I now know whether or not you're going to be around after 2008, and that's great. Like that's the thing I'm interested in predicting, let's say. So I'm going to call this df target for now, and I'm going to totally keep that around. But having a target variable is one thing. What I now also need is I need features. So for every user, I've got my target variable, but I also want to have some features that I might be able to throw into my machine learning model when I make a prediction, right? That's something I might want to do. So fair enough. We're going to do something that's kind of similar, right? We're going to still do a group by, but this time we're just going to see if we can grab some features. So let's do, again, df. Let's just have a look at what we had already. And yeah, I'm going to just do a group by on... Actually, I'm going to do the first 3 rows over here. That way that's always nice and visible, and I can type at will below. But again, I'm going to do group by the player ID over here. And again, I'm going to be doing some aggregation. Let's, again, organize the code just a bit so it's a little bit more readable. But here I can do some stuff with features. And let's say I want to have the max level of the user. That might just be interesting. And, oh, I don't know. Maybe the class, maybe that matters. Maybe some classes are just more fun to play than others. And maybe that holds for playable races as well. I'm just doing the quick and dirty thing, just taking the first one. That should work. And I guess like another thing that I can also do is I can... I think I can call len on this directly. And I can give that an alias, number of rows. And let's just show what this does real quick. Oh, group by has been renamed, of course. So in polars, what you can do is you can select a column and then select how you would like to aggregate that when you're using a group by. But there's also a direct function called length, which indicates like the length of the thing that you're going to calculate. In pandas, you would have to select a column and then call len, but you don't have to do that in polars. But one thing that's kind of cool now is I can say, well, I also know the number of rows that a user has appeared, which is a proxy for the amount of time the user has been playing this game, which is also kind of useful. But what I am also just going to go ahead and do is I am also going to just calculate something that will help me select users. So I can also do, let's just select the date time over here. And let's select the minimum. Because I'm thinking like, if the minimum time. Actually, I don't have to worry about this so far. Actually, let's just do this. I think this is sufficient. So, again, we're doing simple stuff here. So I think this is kind of fine. But one thing I do want to do is you can see that there's a couple of users that only really appeared for just a bit, and that's kind of fine. But those users are probably not going to be interesting to churn analysis anyway. If you've only appeared for 2 times, maybe we can just remove you from this data set. So what I am going to do is I am going to join this target data frame that I made earlier. So that target df, or what did I call it? Df target. I should have an extra closing bracket. There we go. Oh, and of course I need to explain how I'm going to join. So I'm going to join on the player ID. That's something that's in common in both. So that's good. But I guess we can kind of live with this. Like, I have my machine learning data set now, sort of. I have my level, class, race, and you could say that these are my features that I want to sort of chunk in, and this is the target I want to go ahead and predict. Okay. Fine. I guess this is actually perfectly sufficient for now. But what I will do now, just again for good measure, is I am going to drop the player ID column, because that's not something we'll use at all. And I'm also going to do a little bit of filtering, which is the thing I mentioned earlier. Let's do something where we say the number of rows, maybe at least 10, just to have some sort of a proxy here. Like that's, I think, maybe reasonable. All right, I think this is looking pretty good. So I'm going to call this my machine learning data frame over here. Just for good measure, let's prep it for Scikit-Learn. So I'm going to say the array that I want to sort of have go in there. That's my machine learning data frame, and that is the target column. Again, this is the joint data frame, so I have a target column. And I have my X over here. And I think because Scikit-Learn actually supports polars properly these days, I should just be able to say I'm going to drop the target variable, and that should be sufficient. So let's just confirm that that works. Yes, the target variable is no longer in here. And I've got like a whole bunch of machine learning data stuff that I could go ahead and use here. So I think this is looking pretty good. Now, one thing to observe is, like, I am doing this manually just to sort of have you follow along, right? It helps to sort of understand the data set a bit, but it's also good to know that I've done some prep work up front. But hopefully at this point we agree that we've created a machine learning data set, and we can actually do this to maybe train our machine learning algorithm. Let's just close up this code a little bit, because it's the same as what I had before. But like a next step, I suppose, for us to do now is to actually do machine learning. And I have a little pipeline that's not super fancy or anything, but I have a little pipeline that can actually train a model on this. To do that, I'm using a little library called Scrub. That is a library that's being worked on as we speak. But for right now, like, the one feature I really like from Scrub is it has this, what I think is a really neat way of selecting columns. You just have a select calls estimator. And with it, you can construct a pretty nice elaborate pipeline in Scikit-Learn. So I can say, hey, this pipeline consists of 2 parts. I have the level, and I guess I want to add maybe the number of rows as well. Or actually, no, the level is fine. But I have some part of my pipeline, that's the main important bit, that's just a floating point number, or like an integer, or something that's already numeric. But then this other part of the pipeline that actually might have some non-numeric stuff, so categoricals in this case. And I just want to one-hot encode those. And at least to me, I do find this kind of a nice way to look at a pipeline, is you select something, and then afterwards you can do stuff to it. So that, if I look also at like what the pipeline looks like, just conceptually, I do find that this is kind of likable. Like, I'm selecting columns and I'm doing something with it. This fits my mind kind of nicely, and I have a nice little overview of what this model is actually sort of doing. So I'm not really doing anything fancy. I'm really just saying, look, I have my logistic regression. It's just a linear model on these features. Can I go ahead and fit something? And if I were to just fit on the entire set and sort of figure out how well this performance is, then, you know, I can see this number over here appear. 0.65 accuracy, you know, that's a number. I can also do sort of the more proper thing where I'm actually doing cross-validation. That's something I could also go ahead and do. So what you can see here is that I'm saying take the pipeline that I've got, pass it my X and my Y. We're going to do 5 cross-validations. So we're going to split the data up into like different buckets. And then first bucket 1 is going to be the validation set, then number 2, then number 3. I'm giving it some extra scores like accuracy and precision. And at this point in time, this is like the fairly standard scikit-learn way of thinking. And what's probably going to be happening next is we're going to be looking at stuff that we can do to get these numbers to go up a bit. Maybe by doing some feature engineering or something like that here as well. And although that's all fine in a way, we've also just stepped in a massive trap. So we've actually done something quite horrible at this point in time. And the thing that's so scary about this is that it's also like a silent error. No warning was raised, but we did do something right now that is definitely cheating in machine learning. And to help with that, we are going to have to look back at what features we've created. So I have class, I have race, I have the number of rows, and I've got my level. So let's sort of go back up here. And I'm going to do some drawing in this to sort of make my point quite clear. And in order to do that, I'm going to grab my drawing tablet, and hopefully by doodling, we get just a little bit more context. But okay, what did we do just now? I just grabbed this side. Let's make that permanent. So I grabbed this side of the data frame, and I'm saying the information here is going to help me get this variable y. So whether or not you appear in this period of time, that's going to determine whether or not the target variable is 1 or 0. That determines the thing that we want to predict. So that's kind of fine. Like, we need that in order to construct y. But now let's talk about constructing the features, which is the x variable typically. Like, that's the stuff the machine learning needs to explore and find patterns in to maybe predict this variable over here. Well, then it makes some sense, I would argue, from a methodological perspective, that you're allowed to grab features, but maybe only from this space, so to say. And the reason is that if we're going to be making a prediction in the future, that means that at this time split here, we can only use the information that's known to us right now. So that means that we can use all the information in this period of time, but it would be cheating a little bit if we are able to grab information from this period of time. Okay, so far so good. I hope that point is clear. Like, we cannot cheat. We have to only limit ourselves to information that's actually historical. We can't look forward if we're going to do evaluations. But now we get to the thing of, like, what were we actually calculating? Well, I was calculating the max level, but I was also calculating the number of rows. And you might remember that I was calculating the number of rows on this entire data set. And same thing with the max level. And here's kind of the thing. Imagine that a new expansion of World of Warcraft comes out, and in that expansion, we allow players to have a higher level than before. That's something that might happen. Well, that means that users that have a level 80 as a maximum level, let's say, instead of level 70, those will be users that appear in this data set. And there you can kind of smell from a distance that, oh yeah, if I have a very high number of rows, that might be because the user's actually spending a lot of time in this period of time. And if we have a very high max level, that might also correlate with being here. So we need to really do our best to split these two worlds in two. If I'm going to be constructing data sets that are appropriate for machine learning, then I really got to be sure that whatever stuff that I do in my data frame, that really needs to respect this boundary. And right now, we've not done that. I'll put the screen back. But with this in mind, let's sort of now revisit the code that we wrote just now, right? So I'm going to scroll down. Again, I think the way that we're doing this target variable, that feels fine, right? So for each player, we're going to say, are you past a period of time that we are interested in? But the way that we're going about this is, of course, kind of cheeky. Preferably, what we would like to do up front here is maybe do something like a filter. Something that's going to make it absolutely sure that we're not taking data into account that we shouldn't use. So in this particular case, I might want to do something like, hey, take that date time column, right? And let's say that the year has to be strictly less than 2008. Did I do something? Oh, right. Year is a method, so I got to call that. There we go. This already feels a whole lot safer, because now these aggregations are not going to be containing information from the future. And this is like, note by the way, that this is a fairly simple example where the machine learning features that I'm doing here are kind of like a demo of sorts. I'm not really doing anything complex. But if you were doing this for real at a business and you would have like more complex aggregations, making sure you do this actually becomes more and more important because it's really easy to forget. Because as you might remember, we didn't see any warning messages of stuff that happened here, because from the perspective of Scikit-Learn, you're just passing proper matrices and things that Scikit-Learn needs. It is totally possible for you to introduce a data leak yourself, and it's going to be very tricky from the Scikit-Learn side to detect that. I'm kind of curious now, so what I'm just going to go ahead and do is I am going to rerun some of these numbers here. So let's just rerun this. All right, so the accuracy actually went up when we did this. That is interesting. But of course, we have to remember that accuracy might not be that interesting because, yeah, so we might predict that everyone is just churning. Like something like that might be happening to the model. So I'm a little bit more interested in the precision, so we'll see about that. If I just have the quickest look, it seems that precision is around 70% or so. Right. So I'm still a little bit suspicious of what's happening here because I find that these numbers are really, really quite high. But I guess the most important thing for now, at least, is to admit that these numbers are just different. And that's just properly scary. If there's something amiss with the methodology on how I create my variables here, then I'll be optimizing and I'll be doing grid search with numbers that just don't matter. And that's the tricky bit. Machine learning, because of this phenomenon, still requires a fair amount of like human attention, so to say. And there are definitely still things that can go wrong, even if you are doing good practices like using a Scikit-Learn pipeline and using cross-validation and stuff. Let me actually check the chat, because I've not done that yet. Chat. I see Magda giving some nice comments there. Good. These are good comments that I will get to in a bit. But one thing that I was thinking, like, this has been on my mind for a while, like this particular issue. So I was kind of thinking, what might be a good way to deal with this, like in a somewhat general level? Because I could do something very specific for this data set, but it might be just a little bit cleaner if I can come up with something general. And this has led me to make a thing that for now I'm going to call Scikit-Churn. It's a bit of a joke name, and I hope it makes people giggle, but it's a repo that I've got on GitHub. It's not something I've published to PyPI. Again, it's fairly experimental. But the thinking here is that I can imagine that you've got a lot of these temporal effects in churn land where there's a boundary that really matters, and that boundary can require some information from the future in order to get your label, but you can only use information from the past to construct your features. And I kind of needed a utility function to just make that a bit nicer for me. What might just be fun to show as well is just the repository, mainly because the repository has some nice diagrams that I've prepared. So I'm going to go to Scikit-Churn. Right. So again, this is my personal repository. I don't want to necessarily suggest that my colleagues over at Probabl are also working on this. It's just this does revolve around some stuff we are eager to explore, but I must stress this is like experimental stuff. But the main thinking that I've got with this is you do have these use cases in business where there's definitely a input period and there's definitely a checking period, and you need both in order to have your X and your Y variable. And in order to make sure that you don't accidentally put stuff from the future in, I just want to have some sort of a safety mechanism. And the way that I thought about that is maybe it makes sense to just have some sort of a function where you're able to give it your big data frame, and it can just automatically generate these input and checking periods with corresponding X and Y values as well. This is just one way of thinking about the problem, I should stress, but it is a way of thinking that, at least right now, I think might be useful. So what I would like to share is just the implementation of this. So what I've done is I've made this dataset generator function, and the way that the way that it could work, I should say, is that I have an information period, I have a checking period, I have a start and end date. I can tell you how big of a step I want to make, and I can also declare upfront which column in the data frame represents the timestamp. And effectively what I could just do is, build a generator as you might normally. But this time what I'm doing is I'm upfront saying, well, there's a very explicit training information table and a validation information table. And it's this train information where I'm definitely respecting the start and end period. And that's actually something that's going in here. So what this will do, I'm going over this a little bit quickly, I apologize, but there's a dataset generator here. I'm able to get my X and Y out like so, give it lots of scorers, and then still do the cross-validation thing as I did before. And then I see some warnings of convergence, but I'm going to ignore that for now. But then here I do get a feeling that I might have something that's just a little bit safer, so to say, because up front I am really making a conscious split between the train information and the validation information that I have available to me. Like the checking period and the input period. Those are two separate tables before I do any kind of feature engineering. So this is pretty cool, but this is something that's like really, really specific to this particular data set. And what I kind of wanted was just some sort of way that this might work for a more general suite of data sets, because maybe not every data set will have a player ID or like a race or a class or a level. So to make this somewhat generic, and this is also the main feature of the repository that I just showed, I have made this churn dataset generator function. The way it works is basically just as I laid out before, but what I allow you to do here is I allow you to pass in the user ID. That is to say, what should we group over to construct this idea of a user. Just like you have to pass the time column, I also require you to pass some sort of user ID name. But then you can also pass a feature pipeline, which is a basically like a polars function that does all the aggregation that you're interested in. So inside of polars, I can just pipe that feature pipeline onto this training information. So inside of this, you can definitely imagine we're going to do sort of a group by the player ID, and then all sorts of logic can definitely go in here. But again, because this function makes sure that we separate the checking period and the input period, this should be safe. Unless I've made like a typo or like an implementation thing that went wrong, I can imagine this will actually introduce a whole lot of safety. And that means that if you were to use this on maybe a data set that you own yourself, you would have to make a function called a feature pipeline like this. You could do, again, your grouping by, your aggregation, all sorts of custom logic can go in here. But then this is the function that you pass together with the user ID, and then that should be enough for me to construct these XY pairs. Unless I've made a typo somewhere. Oh yeah, I renamed that function, so I should rerun this again. I'll dive into that a bit, but at least I hope at this point, like the picture that I'm painting, like the thing I'm interested in sort of building, that's hopefully clear at this point. Like there is a genuine concern that if you have like a temporal difference and you're not careful about what you do in data frame land, that you are going to be coming up with faulty metrics, simply because there's data leaking in from the future. And the thing that I find particularly scary about this is that there is no real like signal. Like this can be a totally silent failure, and it's very easy to be in this sort of seductive area where you want to improve your grid search numbers, even though those grid search numbers are pushing you down a bad path. So I hope that picture at least was somewhat clear. Okay, having said that, this now sort of kind of a long introduction. I thought it was going to be shorter, but hopefully this was at least useful to some of you. What I am going to do now is just have a look at some of the mistakes in this code, because I do want this to I don't want the live stream to just have functional code. But once this is working, I'll definitely have a look at some of the responses I'm getting on YouTube. If there's any questions about this or ideas, I am definitely open to that, because there are still like a couple of open questions that I have with the current implementation. So the dataset generator has got an unexpected keyword argument user ID. I have a function here called the function name is churn dataset generator. I think that's the implementation mistake here. Yeah, there we go. There we go. Actually, one thing I am interested in running just real quick right now, so I'm not doing any filtering over here, so let's just run these numbers one more time. Right, so actually let's rerun this notebook, because I might have gotten some stale variables. I'll just quickly do that. So I see very high numbers. Yeah, okay, so that's actually kind of interesting. So if I rerun everything in sort of the bad way, then the accuracy and precision scores seem to be like super high, like I'm getting to 1% right now. Probably that's because I'm leaking data from the future with that level and with that number of rows. But if I were to use my generator down below here and then check the numbers, then I'm definitely way more pessimistic. Then I see like a 90% accuracy instead of closer to 1. And I see a test precision score over here that's also definitely lower than 1. This is more like 60%. So this is also something that I would expect given this data set. The reason why we get such high accuracy numbers and precision numbers is because we're definitely leaking data. So that's, yeah, okay. So that was the thing I was hoping to confirm, and that's also something I've confirmed just now. So that's, okay, so that's good. Something I was hoping to get at. But now there are some people who are asking questions, so I'll just dive into that. I'm also zooming out just a little bit, so this function is on display. Also, feel free to tell me if I need to zoom in a bit, but I think this is still legible on YouTube. So someone is asking, does the end date refer to the max date in the dataset, or does it refer to the date where you want the train to end? So the way that I'm going about this right now, and there is definitely like a good conversation to be had here about the user interface, because the fact that you're asking this question does suggest that I might be able to make it just a little bit more clear. But the current implementation, at least, so like there's an input period, and this says how long is that input period, and then I'm saying when is the checking period. I'm starting somewhere and I'm ending somewhere, and I'm moving everything with steps of a month. So it's kind of like a sliding window thing that I'm doing here. So with that in mind, there's not really there's a start date and an end date, and I'm taking steps in between. But as you can imagine, if I have my input period and then my checking period, those two things together keep on sliding upward until they hit the end time that has been configured here, like the end date. I'm not going to exceed that. So I'll be taking steps of a month or whatever you configure, and once I hit the boundary, I just stop. It deserves to be mentioned that this is actually something that's not necessarily perfect, and something I have actually thought about, because one thing you can imagine is that it's great that you've got an input period and a checking period, but the current implementation has like a tiny sliver of time in between, and maybe you want to have like a good month in the middle there, just to make sufficient distance between the input period and checking period. From a methodological standpoint, I can imagine that that might be more useful, but also from a business case, that might be more useful. You might be more interested in predicting, hey, is this person going to still be around 3 months from now? So then you also want the checking period to be 3 months away. Another thing you could also wonder is like this input period right now, as is, it is moving forward. I think that's somewhat reasonable, but you might be of the opinion, well, for my use case, it actually might be more sensible to just have that input period grow. So not have it move, but actually have it start at the start date and just keep on growing from there. To a large extent, these are all settings that we can maybe allow for, but these are settings that currently, at least, are not implemented, I should say. Another thing you can also maybe ponder here is that the implementation right now says, well, I've got my x variable and my y variable here, and I've also got like another one over here. So I've got another x and another y, right? And right now I've got a generator that's going to generate all these separate x-y pairs. And that's really cute, but you might wonder, well, it could be more useful that we just concatenate all those two things together, such that we have, we just concatenate all the x variables and we concatenate all the y variables, and then we just pass that to Scikit-Learn from there. My current thinking at the moment, well, my original thinking, I should say, is that I thought it would be kind of useful to also understand how the performance might change over time, which is why I've opted to go for the generator approach first. But again, this could also be a flag or a setting. So one downside of doing the generator approach is that if you wanted to do something in parallel later, having one x and one y at a time does limit does limit you a little bit in terms of parallelism that you might be able to get from joblib. Then again, it's also not the worst, because you as a user can also just iterate over the generator and construct your big X and your big Y manually yourself. It's not the most effort. But there are definitely still things that are interesting to sort of think about in this domain. Like another idea that I've had is that maybe part of the problem here is that this input period right now is kind of like a batch, and I'm calculating something per user. But you could also imagine that I want to calculate something that's more rolling. That is to say, every time that I see the user do something, I might want to update the features. But maybe it's also a bit cheating to sort of flatten everything I know from the user, because maybe something over time is happening as well. And I could also attach that to a target variable. It will depend a bit more on the use case, I think, if this is going to be interesting. But there is definitely some thoughts that you could have there as well, because right now I'm definitely aggregating, which could be seen as throwing away some of the knowledge and the data in the middle. I'm seeing another pretty good question as well come in. How would one aggregate features over two different input periods? So some features might be over the lifetime, and others might be quite recently. So that's a pretty good question. A lot of this will depend on the use case, to be honest. So one thing I do want to stress, adding more than one input period can be seen as a complication, which can be fine, but it will be good to confirm if the business case has a good reason for that. So one thing I like to think about is okay, suppose I were to use this in a business context now, then okay, imagine, if you will, at this point in time, I get a list of users that might be about to switch. Well, how can I use that information to make my business better? Well, maybe it's not so much the fact that users are about to switch. Maybe we also like to be able to predict why they are switching. If they just no longer feel like playing the video game, there's maybe not much that we can do. But if they feel that it's just a little bit too expensive, we might be able to give them a bargain or something like that. But in order to make that decision, I might need a different input period. So let's try and have that be leading, so to say. That said, I think the current implementation does technically allow for it. So this feature pipeline thing that I have got here, I am free to do whatever I want. So I am able to say, well, let's aggregate looking at the last 3 months, and then do another aggregation where we look at the last year, and then we concatenate those two things together. That is still something you can totally do inside of this one function. The main point is that what this function will not allow you to do is grab stuff from the future. That's the protection that you're getting. But besides from that, you are free to do whatever thing you like in here. Theoretically, like, one thing you could do is, like, if you... Yeah, there is actually a way you could break this. So one thing you could do is you could do something like secretly make a table that's from the future anyway, and then do a join on, like, a cheeky table that you're not allowed to use, right? That's something you can totally join here. But assuming, like, doing that would take, like, a conscious effort to try to break it. What I'm trying to do here is prevent the accidental mishap. But yeah, to answer the question about the feature, you can do lifetime stuff inside of here as well. You can look back as far as you like. So you can do something like, okay, these 3 features are from the last 3 months, and these 4 features are from, like, before, and etc. That should be totally possible. So let's have a quick look at the time. So it is past 1 now, so we're almost at an hour. I hope that this has been useful to people. If people have questions, like, I'll definitely be around for another 15 minutes. But I guess, like, one thing, if this sounds interesting, feel free to hit me up on GitHub. Again, this is an experimental idea that I've had. I've discussed it with, like, a couple of colleagues, but if people have, like, genuine feedback on this, especially if it relates to Scikit-Learn, like, do definitely tell me. Like, let me know via the issues or whatever method you like. You can also hit me up on the socials, but there is definitely, like, an area of concern here where we are definitely eager to get some opinions from industry, let's say. I feel like this is a big problem, but if people feel otherwise, I mean, do tell me. And I guess, like, another thing, there you can also go to the Probabl website, and I should, I guess at this point, maybe move my head a bit to the other side, because then you can see the button. But we do have this contact us button over here. So definitely, if there's any information you would like to pass on to us, like, oh, there's, like, a live stream idea or, like, some other stuff I'd be interested in, that contact us button, that we will read that. So, like, if there's any suggestions that you might have, do let us know as well. That's, like, a good way to contact us. But yeah, other than that, for people who are still here, definitely keep asking me questions. The main thing I'm also eager to know is if there are other topics people would like me to explain. So right now, this was very much a prepared live stream, but I am also perfectly open to doing a little bit more informal live coding live streams where someone is asking, like, hey, I've got this data set, how should I encode it? Or, like, a specific topic in Scikit-Learn. That's also stuff that we could explore during this time. It is definitely, like, a bit of an experiment. So if there are ideas that people have, definitely do let me know. Cool. So I'll keep an eye on the chat, and if not much is happening there, then I think I'm gonna go to lunch, but people might do something else. So people are sort of, I think Magda is asking a question. So this live stream will definitely be saved. I'm totally going to try that. If I, again, don't have the mishap that I had earlier, this should all be saved on YouTube. And that is something that, like this, we are intending for this to be out there. The code that I'm showing here will also appear on, I'll add a link to the code, but you can also find this code if you go to my personal repository, Koning on GitHub, and then the Scikit-Churn. That's you'll be able to find all the code in this particular notebook as well, and you can totally play around here. But yeah, the whole point of this is that this is going to be recorded and also out there for posterity. We are not doing these live streams just to be live. The hope is that interesting discussions happen and that we record those as well. So all this stuff will be saved on YouTube, so you can watch it afterwards. And again, like, it's also perfectly possible that someone explores my code over here and finds a massive improvement. That's also totally possible. The main point that I want to get at for this live stream is just the idea of a temporal data leak. Like, that is something it's hard to say how common it is, because it's not like a mistake that hits you in the face. It's one of those mistakes that is very silent, and it also makes them very scary. So yeah, hopefully that's the main point I wanted to get across, and I've got some ideas on how to remedy that. But if people have other ideas, I definitely would be all eager to hear. So again, I'll wait around for just an extra bit to see if people have questions, but if not, then this might also just be a good first live stream. I hope people enjoy it. Leaks from the future do sound scary. Yes, that's a good comment, and I agree. All right. I can also see that the viewership numbers are going down at this point. So yeah, we had 20 people join in. That's definitely kind of nice. Thanks everyone. Thanks for tuning in. If you have ideas for like next topics, hit me up on the socials or on GitHub. We're definitely all ears. Hopefully this was a fun experiment, and we hope to see you around. Have a good one.